Okay, thank you for the introduction. Imagine to have data describing all the actions made by players in all the soccer games in the world. From, let's say, La Liga in Spain to Serie A, from the Champions League to the World Cup. And then imagine that you are a soccer manager or a coach who want to hire or buy the best player playing in a specific zone of the soccer field. Which software tool would you like to have to make this choice, to help your decision? Well, presumably, something like that, okay? A very simple tool, here is a very simple Python notebook, where you can choose an area of the soccer field, and this tool automatically finds all the players with an attitude to play in that zone and make a ranking of these players.
So although such a desirable tool may seem simple to implement, there are some challenging questions to address in order to realize it. First of all, how to rank players according to their playing quality. Second, what is playing quality and how can be computed from a performance? And finally, what is a performance and how can we define it?
Fortunately, nowadays the Internet of Things and the data revolution help us answering this question. Consider that nowadays data describing all the events made by players during game is massively available thanks to the collection performed by devices, technologies, and semi-automatic methodologies. This is an example of all the events made by Messi in a game in La Liga, in the Spanish National League. You see that Messi made, for example, 47 passes, the red arrows, and you know the position where these passes are made. Then you know that Messi made 5 shots, 15 tackles, 8 take-ons or dribble, 4 crosses, and so on and so forth. Okay, this is a visualization of the performance of Messi in that game. Actually, there are several ways to extract performance from this kind of data. The simplest way is just to count all the events of each type that the player made. There are, of course, more refined ways to construct a performance. For example, we can compute from here the dangerosity of Messi. If Messi plays very close to the opponent goal, is more dangerous. Or we can compute the contribution of Messi to his team. Or again, we can compute the accuracy of Messi's ball possession. Consider that technically, this visualization comes out from a manipulation of raw data collected by a company in Italy called Y-Scout, which is the leader company in the world for soccer and talent scouting. And the data has the following structure. Basically, each event is a Python dictionary or a Python dictionary-like structure. We have several information attached to each event. For example, we have the type of the event, a pass in this case. We have the timestamp on the event. It is when this event occurred during the game. We know that in this case, the event occurred at the 8th seconds in the first half of the game. Then we have some identifiers to identify the match, the player, and the team associated with the event. And then we have some information regarding the position. So for every event, we have the position where the event occurred. And finally, some tags. A tag is a meta information attached to the event. For example, here we know that the pass was accurate. In other words, the pass successfully reached the destination player. Note that we have, in average, per every game, 1,700 events per match. So the distribution is, in other words, peaked and this number. And given the structure of this data, the natural way to store it is using a NoSQL database. In our case, we use a MongoDB.
So once we have defined performance, so we have an objective way to define performance, we need to define the concept of playing quality in order to evaluate such a performance. So the first solution of this problem is to use artificial intelligence to imitate the way we, as humans, evaluate soccer performance. Clearly, in order to imitate the human, we need a trace of human evaluation of soccer performance. So now the question becomes, where can we find human evaluation of soccer performance?
This can be one of the answers, soccer player ratings. As most of you probably know, every Sunday, well, basically every day nowadays, sports newspapers publish the so-called soccer player ratings, voti del fantacalcio. They are numeric evaluations of performance ranging from 0, meaning unforgettably bad, to 10, which is very rare, and mean unforgettably amazing, let's say. So these ratings indicate the perception of performance from the perspective of the sports journalist who published these ratings on the sports newspaper. You probably better know these soccer player ratings grouped by the so-called pagelle, which are published every day after a game, and see that every player, in this case Napoli versus Spal, every player has attached an evaluation with a numeric number and also a small text, meaning, let's say, that is the comment of the sports journalist regarding that performance. Well, in order to get a large enough number of human evaluation of soccer performance, we downloaded from the web all the soccer player ratings for all the games in Serie A for 2 entire seasons, 2015-16 and 2016-17.
So before everything we performed a statistical analysis of such human ratings. And as you can see from the picture on the left, from the A picture, the distribution of the ratings among the 3 newspapers, so we got ratings from Gazzetta, Corriere, Tutto Sport, and this newspaper has identical distribution. So the distribution is peaked at 6, as you can see in the right picture. The standard deviation is really small, and it's really rare to have ratings that are higher than 8 and lower than 4. And this kind of rating system is borrowed from the Italian school rating system, as you probably already know. Actually, we have some outliers. As an instance, we have only 110 in our dataset, that is Higuain, when he became the top seasonal scorer of all the times in Serie A. And we have also just 1-3, that is Rafael, it's the goalkeeper of Verona probably, who punched an opponent in the face. So these are the only 2 cases with
outlier, let's
really say. So it's like in the school, to get a 2, you really need to be really bad.
Really bad.
So, but the fact that they have the identical distribution does not mean that every journalist is giving the same rating to the same performance. Indeed, in this scatter plot, you can see that in the gray areas, we highlighted the areas of disagreement. So there are many cases, some cases where, as an instance, the journalist from Gazzetta gives a 5 to a player, while the journalist of Corriere rates the same performance as a 7. So we use this scatter plot and the corresponding correlation, that is 0.75, as an indicator of agreement between 2 human judges.
So in other words, this number 0.75 expresses the concordance between 2 sports newspapers, or 2 sports journalists, or 2 human judges, let's say. What's the point now? Well, the point is now to try to construct an algorithm to imitate the way humans assign ratings to soccer performances. As you probably know, one of the ways, probably the most common way to do that, is to use machine learning, in general artificial intelligence. And in this case, we want to construct an artificial judge which is able to assign a rating in the range 0-10 to each soccer performance. So how to evaluate how good is this artificial judge? Well, we use that kind of number, 0.75, the correlation. So we say the more concordant the artificial judge is with a human, the better is. Okay, the closer is to a human judge. Actually, and unfortunately, if we build the artificial judge, we get a correlation of 0.55. So we are quite far from the human judge, right? So the artificial judge is concordant to a human at 0.55, while two humans are concordant as 0.75. So there is a missing ingredient, right? So something is missing in the equation. What is? Well, probably our idea was that the context of a game could be the missing ingredient. In several contexts of human judging, context is known to act as a strong bias in the evaluation. This is true, for example, in the judicial court, where unfortunately sex and race is a strong bias in the evaluation because black people is condemned more usual than white people, unfortunately. But also in the evaluation of artistic performance, it has been observed in scientific literature that the geographic provenience of a particular person is a strong bias in the evaluation. So in order to verify if this hypothesis is also true for the case of soccer, we retrieved many contextual variables. This is only a subset of the contextual variables we retrieved. But just to give you an insight of what they are, the first one is where the game is, home or away. The second is what we call quote, but is the expectation estimated by bookmakers on the outcome of the game to be. Le quote scommesse. Then game outcome, that is the true outcome of the game. And then some information regarding the player, so which are not strictly related to the performance, that is to the game, but related to the player. That is the age of the player, the popularity of the player as estimated, for example, from the access to the Wikipedia page or Twitter, and the nationality of the player. Interestingly, if we add this information in the equation, then the artificial judge becomes more human. You see that the correlation strikingly is from 0.55 to 0.78. So we are not perfectly human, but almost human, meaning that it is very difficult to distinguish between ratings assigned by the by the machine, and the same ratings assigned by a human. Actually, we did a sort of a Turing test and asked some professional sports journalists to provide an opinion about the artificial judge and the human judge, and none of them were able to distinguish between the artificial ratings and the human ratings.
So let's now open the artificial judge. So let's now inspect his brain in order to understand how he is reasoning, so how he's perceiving a performance and how he's rating such a performance. And this radar chart visualizes the importance of each technical or contextual feature to a newspaper evaluation of performance. So the more important a feature is, and the more such a feature is close to the edge of the radar. And on the contrary, the more is closer to the center, and the more is equal to 0. So its importance is equal to 0. And we can see here for the case of forwards that obviously goals are the most important things for them, but the second most important thing is the goal difference. So the final result of the game. So if, as an instance, Veretout from Fiorentina scored 3 goals, but they lost, probably he didn't get an 8 as he would if the team won. An extreme case of contextual bias is for defenders. As you see, the most important feature for defenders are mainly contextual. So goal difference and goals suffered. So basically, this means that the evaluation of defenders is based almost exclusively. Sorry for it's hard to speak in English here in Florence between Italians. Anyway, This means that basically the evaluation for defenders it's only based on is context. So if you are going to hire defenders for your fantasy game, just hire defenders from teams that are winning. No matter their performance, it doesn't matter any of their characteristics. Yeah. They just need to win the game at the end. So far, we as humans evaluate a performance. So we are strongly biased toward contextual information, and we would assign the Ballon d'Or to a player who had won many titles and games with his teams, instead of evaluating his single performance. But can we find a better solution that overcomes the bias that we have as humans? Our proposal is to try with a data-driven solution.
Yeah, this is our solution, Playe Rank, which is basically a Python package. And the idea of a Playe Rank is that human evaluation is strongly biased toward contextual features. So let's try a fully data-driven approach without using contextual features. Of course, it can be really simple to implement, but there are some challenging technical problems to solve. This is the architecture of Playe Rank. And first of all, we have a database of events, and we use the PyMongo Python package to extract the performances from raw data. Then we have to solve the two challenging problems. The first one is the feature weighting. As we saw before, if we open the black box of the artificial judge, we can infer the importance assigned to each variable from the judge. We don't have such an information in this context. So we have to find a way to automatically infer the importance of every feature, because, of course, a goal is much more important than just a pass at the center of the field. The second important problem is role classification. We have to understand where a player played during a game. This is important because it's completely meaningless to compare a left back with a forward. They are expected to comply with different tasks. So we provided also an algorithm to automatically detect the role of a player by observing the average position during a game. And we did this task by using the well-known scikit-learn Python package. Once we solve the step 1, 2, and 3, we go to the core of Playe Rank, which is the algorithm to compute the player rating. That is the evaluation of the performance, the data-driven evaluation of performance. That is the rating of that performance, but computed in automatic way. Once we have, for every performance of the player, his rating, we can simply use pandas to make an aggregation, a group by basically, and create a ranking of all the players from the strongest to the weakest. And then finally, once we have the ranking, step 6 allows us to create the tool we showed you in the very first slide, that is the search engine. But let's see now in detail all these steps and how can we compute them by using this Python package.
So first of all, this is the data set we use to build and to test such a framework. So we aggregated 14 million of events generated by 1,000 of players on 7,000 games from the main 5 European leagues, so La Liga, Bundesliga, Ligue 1, Serie A, and Premier League. And every performance is described by 150 features, so passes, shots, takeouts, and all the possible variation of this kind of events. So as you saw, we know how to automatically get the human rating of a performance, and on the left picture you see how we can evaluate, we can get a human-like ratings from a performance. So these are the ways to get such a rating. But how can we get a data-driven set of weights that is as most objective as possible? So the solution we propose relies on the outcome of the game. So the outcome of the game is the target variable in this case, to build a machine learning process that can give us a set of weights based this time on the outcome of the game and not on the human evaluation of on the human ratings. And we start this feature weighting process by aggregating all the data regarding to a team on a match, and aggregating also the target variable for that match, that is the outcome. So as you see from the bottom plot, we have a W for a win and an N for a loss or a draw. And on our training data, we have for each feature, we have the performance of the team compared with the performance of the opponent. So this is our training data. And to get this, we rely on MapReduce API provided by PyMongo. Now that we have training data, so we have a matrix X with each row containing the performance of the team and a vector Y containing the label of of the corresponding label of each performance, we can encapsulate a machine learning process on a custom class. In this case, we use the name waiter, so we build a custom package that will be available on GitHub. And in this case, what we do, we reply the same structure of scikit methods classes, and we train a model, a machine learning model using our training data, and we get finally a set of weights that is the importance of each feature to get the most reliable prediction of outcome given the performance. So our machine learning model just take the performance of a team and try to predict the final outcome. At the end, we get the weights of each feature. So here we highlight the top 10 and the bottom 10 features, and what we discover is that the worst thing a player can do on a pitch is getting a red card, while the better things are providing assist to have a goal opportunity, so to have a shots and a score opportunity.
So now we have the weights, okay, but the other step is to get the role of the player. Why we need an automatic methodology to get the role? Why don't we use just the classical definition of role, that is defender, left back, and so on and so forth? Well, mainly we need this step for two reasons. The first one, as I said, it does not make sense to make one ranking for the Ballon d'Or. Okay, we cannot compare a forward to a goalkeeper or a defender. They do different things. The second one is that the concept of a traditional role we have in mind is quite obsolete for two reasons. The first one, because the role can change from game to game. One player can change the role according to the needs of the coach and the needs of the club. And second is that a role can change within the same game. So from the first and the second half, a particular player can change role. So we need an automatic methodology to understand which is the role. The solution we use is very simple. First of all, we extract for every performance the average position. Since we know for every event the position of the event, then simply we can compute the average position of a player as the average of position of the position of all the events he performed. Okay, so if I perform an event here, another event here, this is my average position. And this is a very simple pipeline in PyMongo to do that. We obtain something like that. This is a portion of all the performances we have. Each point is the average position of the player during a single game. So we have a player who played mainly here, then a player who played here, and so on and so forth. What we have to do now is to understand if there are clusters in this kind of noisy data, and to do that we use, of course, clustering techniques implemented in scikit-learn. So we create this object role this class role clusterer, which is based on the well-known k-means algorithm. K-means is a very common algorithm in data mining, which allows for the detection of clusters. The only input is the number of clusters. So this algorithm automatically tries several cluster partitions and is able to find the best one. So if we use this code to generate the role, this is the result. We have the same points as before, but now they are colored by the cluster. So the algorithm automatically finds 8 classes. Of course, goalkeeper here not considered, obviously, right? So according to the algorithm, there exist 8 main roles in soccer. Some are very clear. For example, C7 and C5 are the defenders. C1 and C4 are people playing on the side, either in defense or in attack. Then we have the midfielder, and we have some forwards. Note that there are some gray points. These gray points are the hybrid roles. That is, are roles that cannot be reliably defined by the algorithm as belonging to one cluster or the closest one. You see that probably the famous the number 10 in soccer, in numero 10, it probably has something like a hybrid role, because it can be something between C3 and C2 on C8 and C2, like Roberto Baggio, for example. So in this case, when we have a hybrid role, we assign both role to the player. So if you played here, for us, you played both in C1 and C6. It's a way to codify a hybrid role.
So we are getting closer to the final result. So now we can recognize automatically the role of a player, so we can group player by role. We know the weight of each feature, so we know
the importance.
Yeah. So we know how every performance could be rated. Now we are missing the last step. So given the performance of a player, we need to extract the value of such performance. And we do that by a simple scalar product. So we have the performance of a player as a vector, then we have the feature weights vector that we saw before, and then we just multiply them. Note that before we didn't take into account goals, mainly because goals are particular events. So goals are the results of a game. So in a sense, they are deciding the games by themselves. So we take out goals from our machine learning process, but we can take them into account now. So we can define a parameter alpha in order to divide the importance of goals and the technical performance, and the user can decide whether goals are important or not to his ranking. So alpha is varying between 0 and 1.
In other words, Playe Rank evaluates without considering goals. So the evaluation is without considering goals. If you like to consider goals, you can force the algorithm to include them.
Yeah,
okay?
even because ranking players by goals scored is quite simple. A Commodore 64 probably is enough for that, so we don't need any machine learning for that. So the last thing we do in order to get our rankings for Ballon d'Or is to aggregate all the events for every players and every role, and again we rely on MapReduce API of PyMongo. Then we instantiate an object of class rater that contains the methods we see before, the equation we see before, and then we, given our performance as a matrix X, we just give ratings to every performance. And at the end, we have our Ballon d'Or.
Well, of course, to get the Ballon d'Or, we have to aggregate the evaluation of the single performances, because what Playe Rank does is the evaluation of a single game of a player. But of course, the strength of a player is an aggregation of the quality of all the games he played. So first of all, we have to we can do it simply by using pandas. We have to aggregate this value and obtain, for example, the average playing quality of a player. So finally, we can get the Ballon d'Ors classified. That is, since it is meaningless to compare a forward with a defender, it is meaningless to provide one Ballon d'Or. So we provide 8 Ballon d'Ors rankings, which are this one. So these are all the clusters we saw before. And you can easily recognize well-known faces. Not surprisingly, the best player in this cluster is Lionel Messi. immediately followed by De Bruyne, which is actually evaluated as a very expensive player nowadays. And then you have Suarez. Not surprising again, the best player in this cluster is Cristiano Ronaldo, followed by Neymar. Then you have Müller, Robben, as midfielder, Pjanic and Kroos are the best one. Nolito, Jordi Alba, Bartra, and so on and so forth. So what is interesting is that this ranking is made by the algorithm in a completely automatic way and without considering goals. It only observes what the players do on the field, and according on the event they produce, is able to produce this ranking. Okay, so probably if we include, and actually this is true, if we include the goals, this ranking can change a little bit, but not so much. So the other interesting result is that even if we just look at the events without considering goals, we obtain a very similar ranking.
Yeah, but you could say, okay, we take 1 year of researching just to discover that Messi and Ronaldo are the best one. Okay, yeah. We could save work, but the important thing here is that actually, okay, Messi and Ronaldo are the best one, but we can compare other players among them. So we can compare every player of every role in an objective way. In other words, we can get a search engine.
Exactly. And the algorithm is completely parameter free. That is, you, human, don't have to specify a parameter. It understands this ranking in a completely automatic way. So finally, we come back to the tool, to the software tool the manager would like to have, which is a it is a search engine where we can specify complex shapes, complex zone on the field, and we would like to have the ranking of players according to that field. The red area is let's say it's the zone selected by a user, Paolo in this case, and we have this number for Bale of Real Madrid and Messi from Barcelona, which is the attitude of the player to play in that zone. You see that Messi is a little bit more prone to play in that zone with respect to Bale, but the interesting thing is that we can finally get a ranking. Actually, we have 3 rankings. The first one is the player rank, the one we saw before. This one is the attitude of the player to play in the selected zone. This is a combination of the two. In this case, we selected more or less the half, the average of the two, but you can also use, not the average, it's a sort of weighted average with some parameter, but you can specify others. And this interesting say that, of course, the best player, the player having the strongest attitude to play in that zone is Robben, but by observing a combination of attitude and strength, of course, Messi will be the best player to hire. But I think you don't have the money to hire Messi, right? So you can go down in this ranking and see, for example, that there are some surprising players like Petagna and Berardi, which have a very good attitude to play there and are quite good also in the player rank, but I think they are a little bit less expensive than Messi, okay? So what's the final tool? Well, the final tool is the same we had at the beginning. That is the simple Python notebook which use player rank to select players and to obtain the best player playing in a particular zone.
So at the end, what did we realize? We realized the engine for such a notebook that not only is the, let's say, the Jupyter notebook that every Python soccer fan is dreaming about, but it's also a useful tool for managers and coaches. And we hope a first step toward the definition of a data-driven Ballon d'Or. So overcoming the human bias.
Data-driven Ballon d'Ors.
Yeah, and at the end, getting something more objective to reward players.
Thank you very much. That was the end of the talk. And just one final recommendation. We are now organizing a hackathon in Pisa in October on this data. So if you like Python, if you like to program, if you like analytics, if you like soccer data, then there will be this hackathon in October when you will be challenged to provide the most innovative and technical solution to a problem in soccer that will be evaluated by a team of data scientists, including us, and also some coaches. Cesare Prandelli will be there, Carolina Morace will be there, and so on and so forth. So come in Pisa. Thank you very much.
Okay, so any question?
In order to evaluate the feature selection, you used as an outcome variable whether the team won or not, and not the goals. So is that the only variable you use to evaluate features?
Yes, in this case, for this run of the experiment, we use that one. Obviously, you can also define different targets. So maybe you can be interested on ranking players on their performance according to the goal scored by the team or suffered by the team. So you could have also different set of weights. In this case, we focused on the result of the game, but actually you can also use maybe the number of shots they made. So you want to find the best player on producing shot occasion, so goal opportunities.
Yeah, basically, the problem is that you don't have a ground truth for the quality of performance. There is no objective number. But the only things you are sure to know in soccer is the outcome of the game. So we changed the problem in the problem of predicting the outcome. Then we aggregated all the features at team level. Once you get the weights, you propagate these weights to the players. And this solution actually seems to work very well.
So yeah, connected to this thing you just said, you propagate the weights of the team to the actual players. And that's the difference, I guess, from the human approach. I guess the weights for each roles were different, but for the data-driven approach, the features, the weights would be the same. So would it make sense, I guess, for the data-driven approach to have features weighted by different roles as well?
We also tried this, actually it's a good question because on designing the experiment, we also tried this approach, but we saw that actually the weights are not really changing. So at the end, the outcome of the match is decided by such features. So even for the other roles, the weights are more or less the same.
Yeah, that's very good question. Thank you. Actually, it seems that if you make this kind of machine learning for every role, is almost the same. And even if you do this machine learning tasks separately for each league, is very similar. So it seems that the importance of features in soccer are those ones. So the difference in the role is not in the importance of the weights, but is in the quantity of that kind of feature you do. We know that trivially, goal is the most important feature, right? This is for everybody. However, of course, defenders score less goals. So the difference is not in the importance of an event, but in the quantity you produce of that event.
Hi guys, congratulations. If I remember well, some of your first work talked about the famous Pezzali score, right? So are you already into the direction to go from the player to the team evaluation or something like that?
We are trying also to explore that direction. So for those of you who doesn't know, the Pezzali score was a paper we published a couple of years ago. And actually, we find out that there is a degree of unpredictability in soccer where any machine learning approach cannot deal with that. So there are those teams who are mainly winning just by shooting one time, and in that case, there is no machine learning that can save you from taking the wrong prediction.
Yeah. Also, let me add another thing. Evaluating a team is more than the sum of the evaluation of the players. And even the evaluation of players is more than just considering his regardless the context. Indeed, the next step of Playe Rank will be to evaluate the players also by considering the teammates and the opponents. Now we consider the players independent, one from each other, but of course this is a simplification. We are also trying to develop some techniques to evaluate a team as their dominance during a game, not only in terms of ball possession, but in terms of creation of opportunities, in terms of space dominance, and so on and so forth. The Pezzali score, which is basically the fact that if you attack a lot, but then you suffer a goal, we observe that it is a peculiarity of some teams. That is, you can win a championship in two ways. You are Barcelona or Real Madrid, so you are the strongest. Or you are the smartest, that is, you are not as strong as the other, but you rely on this Pezzali score to try to be, furbo, to be smart, and try to, suffer less and shot more.
In machine learning, we would say you have a high precision, even though you have a low recall.
Hi, thank you. I was wondering if you thought about the different dispersions for the player in the different roles. Maybe it's linked to the question that you had before, different weights for different roles, but I was wondering about why for attacking roles there's much more dispersion between players and for defending roles there's not.
The main thing is that since this kind of data is focused on what is happening around the ball, so you see a player only if he's making something with the ball, so passing, tackling, or whatever. You see players who are attacking more than defending, because sometimes defending is just covering your zone and cutting passing lines, so preventing other players to pass the players to the attacker, to the forward you are guarding, you are watching. And this is the reason why we have less observation, and mainly we have even, so the events generated by defenders are even important. If you remember the plot before, the main important events are the one related to attacking things, so passing, making assists, or shots. That's the reason why defenders are smaller.
And also, let me add just one thing. For defenders, you basically have less events because the well-known Maldini principle, right? This is quite famous in the sports analytics context. A good defender is not the defender who makes a lot of tackles, but the defender who does not make tackles. Indeed, there is the famous fact about Alex Ferguson, who asked to sell Jaap Stam, that finally went to Lazio, because the number of tackles he was making was decreasing. Actually, that was an indicator of goodness of the player, not the opposite. So you have less events, so the volume is lower. This is why we are now trying to combine this kind of data to another kind of data in soccer, which is tracking data. Tracking data is are the GPS coordinates of the player, the movements of the players during a game, from which you can understand pressure, you can understand the ability of the player to position, and to stop the attack, and so on and so forth. So Playe Rank is very reliable for midfielder and forward. There is a problem of scarcity of data for defenders, and this is partly why you have this lower volume, and partly why we are trying to use, to complement this data with a different kind of data.
Hi, very interesting study, by the way. Congratulations. I was wondering that if you use the fact that a team has won or lost or a game as the response variable in your machine learning study, right? Isn't this biasing the single player judgment towards teams that are winning a lot? For example, if you put a very good defender, let's say Fabio Cannavaro, playing with other 10 dumps and ultimately they don't win not even a game during the World here. this Fabio Cannavaro wouldn't stand a chance to be judged as a good defender, even if it was. Wouldn't it make sense to also define the responses, so the target variables, role-based? So, for example, for a defender, the number of balls or the number of goals coming from his zone, stuff like that. Did you think about that? Do you have plans?
It's true.
I find that a bit puzzling, the fact that you define the roles for the predictors and then you use a global variable like the fact that a team won.
Okay, it's what you say is true and false at the same time. So, in our cases, we are not using the game result as a feature. So we are not influencing the single performance. And furthermore, since we use really many games, so 7,000 games, the fact that there could be some games that has been won with some strange behavior, it's in a sense
mitigated by the larger numbers, let's say.
So Fabio Cannavaro, for your question, Fabio Cannavaro, if he's playing really good with dumb people, you will see that Fabio Cannavaro is a good defender and the other one are dumps.
Yeah, one possibility to do what you suggest, and thank you for the suggestion, is that probably we could change the value, we can invert the variable for defenders. That is, you are a good forward if your team wins, but you probably are a good defender if your team does not lose. In a sense, probably the draw is, the factor that can affect the others. This is one we actually would like, which would be interesting to try. That is to split, the roles in defenders-like people and forward-like people, and to redo the machine learning things by inverting the, let's say, the target class. That could be a hypothesis. We will do and let you know. Thank you.
So, there is, okay, the last question.
Thank you. Very interesting topic. I wanted to ask you something about the clustering, because you said you used k-means algorithm for the clustering, and with k-means you decide the value of k, so the number of clusters. But you decided to have 8 clusters. Even though the number of roles in a football team are way more. And I wanted to ask, why did you decide to use 8 clusters?
So as you see from this line of code, we use a parameter that is k range. So we specify the k ranging from 2 to 20, and we instantiate the method that finds the best k according to the position we give to the method. So 8 is the best split among all the different possibility the algorithm is checking. So 8 is the best way to split the pitch according to the position. And we use this because actually even by reasoning with some soccer coach, they claim the role of a player is just a portion of the pitch assigned to that player, is nothing more. So in that sense, we rely on k-means and on finding this split.
Yeah, let me add just one bit of information. Even here, another possibility is to recursively apply the clustering within each role to obtain sub-roles. For example, to obtain sub-C7 or sub-C5 roles. Interestingly, here we use the average position of a player. We tried many other ways of describing how a player moves during a particular game. For example, computing the vector of his position, then considering splitting the zone into fields and constructing the heat map. But curiously and interestingly, the quality of the clustering from this representation of the position were much worse than using just the X and Y position of the player during the game. This is why we finally come up with this very simple algorithm, I agree. And he finds 8 clusters, but of course this can be also defined by the user. So the Playe Rank provides the possibility to do it automatically, but if you are a coach or a manager and you want to make an evaluation with different definition roles, then you can put it into the algorithm and you can do that.
Okay, so I remember that you can vote, you can rating this talk through the app, and thank
Please not be
Rank.
not be influenced by the context.
And thank you so much.